Now, in the Hartree Fock SCF calculation, it's basically the same idea, except that in the Hartree Fock calculation, you have to take into account spin. Okay, and so this is the equivalent expression that you use in the Hartree Fock calculation. All right. So we're not going to go into detail as far as this is concerned, but the whole idea here is you guess what your function, your orbitals are to begin with, and then you just continually improve it. Okay. And in the Hartree Fock calculation, a common technique is to use a set of functions, simple functions that you can manipulate easily, and a set of functions called basis functions. So like chi sub I here, chi 1, chi 2, chi 3, and so on. And you express your orbital as a linear combination of those basis functions. And a commonly used basis set are known as Slater type orbitals. This is very similar to your hydrogenic atoms. The only difference is you have the function of r here, which is r to the n minus 1. Okay, there is no polynomial in r for this expression, so there is no, you won't see the progression in the number of nodes like you would for hydrogenic atoms. Okay. Now, when you do the Hartree Fock calculation, okay, the exact ground state energy, the energy that you get, okay, you can get the exact energy theoretically by using an infinite number of your basis functions, because if you have an infinite number of these basis functions, you can make it look like whatever function you want, whatever the true function is. Okay, so but in reality, since you can't do infinite number of functions when you're doing practical calculations, you just you can get fairly accurate results by selecting, okay, by using what's called a judiciously chosen finite set of basis functions. So this zeta right here is analogous to your effective nuclear charge, is similar. Okay. Now, when we say we have the exact solution with the Hartree Fock method, you have to realize that that exact result is still an approximation, because fundamentally there's still a problem with the way we wrote the function. We're still writing it as a product of spin orbitals, rather than taking into account fully the electron-electron repulsion term. Okay, so the whole idea here is when you're doing these types of calculations, you start with something simple, okay? In which case you can imagine starting off by just pretending the electrons don't interact. So you have your product of spin orbitals of hydrogenic atoms. And then, so that's your simple model. Okay, so that's a common theme you'll find in physical chemistry. You have all of these simple models. And then what do? You introduce correction terms. Basically what we do here is we made our we made our our nuclear charge adjustable, right, to get better results. Okay, and now a better way of doing it is to actually just brute force do it numerically to calculate those wave functions, those orbitals, and that's what you're doing with the Hartree Fock method. Okay.